All right. Well, welcome everyone. Thanks for joining us today here at the Qt Company booth at SIGGRAPH 2020. Today, what I'm going to do is kind of a walkthrough of what we call our designer to developer workflow. And one of the things that is going to be, that I'm highlighting in this, is that we can target low-level devices, microcontroller devices that previously were kind of required too small of a footprint for the Qt framework. But over the last year, we've been working hard to bring Qt down to the MCU level, and so that we can show some real engaging user interfaces even on these low-powered devices, really enabling edge computing, wearable devices, and that sort of thing. And what's interesting, to our attendees, at this conference in particular, will be some of the unique ways that we're able to bring and interact with common designer tools to really simplify the process of moving from graphical design and concept art into an actual user interface. And so I'll be highlighting that today. We'll be starting with a Photoshop based file here. And so on my screen now, I'm just to verify everyone can see my screen share right now. Should be seeing a Photoshop file of some gauges. Can I get a nod from somebody or a thumbs up?
We can see it, Corey.
You got it? Great. Awesome. So this is a Photoshop file that we've put together with kind of a nice kind of entry point for some gauges that we can turn into some actual application code. So what I'm bringing on here is an extension that is available through the Qt Company. That's a bridge into our design studio, and we call it the Qt Bridge out of Photoshop. And with this bridge in place, what we're able to do is take artboards like this one and convert them into actual application code that can be compiled, that can be run, that can be loaded directly onto devices, as we're going to do today. And so, a couple of interesting things to note: when you design your UI, you're able to kind of build out reusable UI components so that you can reduce the number of exported assets that you have to pass around. You can create components that are reusable in multiple ways. So if you have common components for your look and feel, like your buttons and your sliders and your switches and checkboxes, those can each be exported as their own individual component. And so when I highlight this main file artboard, you can see that on the Qt Bridge, it's exporting this as a component, which makes perfect sense. But within each of the layer groups here, for example, we have the speedometer dial here. This also is a component. And underneath that, in the layers, we have elements of the needle for the speed. We have all the various text elements that apply. And then each of those will be exported as actual programmatic text content. And so basically what we're going to do is export this UI. We're going to bring it into our design studio, manipulate some properties to create some dynamic look and feel. And then we'll take that into our Qt Creator IDE, which is the developer-centric user interface, and compile that into a binary that we can load on my microcontroller from ST today. And we'll take a look at that running on the device as well. So what I'm going to do to kick this off is I'm going to go ahead and update and set my folder so that I can export these. Let me grab that here. All right. So we're going to take this to my DS to MCU assets folder. Make sure the connection is successful, and we'll go ahead and kick off the export process. So what this will do is export all of the image data, obviously, as well as a metadata file that's a JSON file that gives the tooling a way to generate the source code. And then our design studio will handle converting that over into actual functional QML code. So while that's running, I'm going to go ahead and create a new project in our design studio. So this is our Qt Design Studio tool, and it's really our UI and graphic designer focused IDE. We'll go ahead and create a new one. It's going to be a Qt for MCUs application. And I'm going to name it DS to MCU. I'm going to choose a resolution. So our device is an 800 by 480. So we'll start with the 640 and adjust it. And this takes us into our kind of boilerplate hello world application. So we have here in the navigator, you can see we have a rectangle as the background with a text element. It has a common set of text properties. So you see hello and the name of our project, DS to MCU. And we're actually going to go ahead and delete that text because we're going to replace all of this content. All right. First thing I want to do is update the size so that it actually matches our target device. So I've got a couple of options to do that. Right here in the UI, you can see the width and the height values. So height is correct at 480. Width, I want to set to 800. So I'm going to go ahead and do that. And so as you can see from the file name, we're defining a QML component called Screen01. And if you've never seen QML before, I want to highlight what that is. It's a declarative programming language that's basically based on JSON. So it's very similar to the Swift programming language. I need to update the width in this container file as well. And so what you see is that QML files are composed just hierarchically from an item, which is the most basic type. And then you can instantiate subcomponents. They're children of that type by just declaring them in line here. And so this is the main file for our application, ds to mcu.qml, and it instantiates a Screen01 component, which is what we're going to be manipulating over here in the design tooling. So we've got our width and height set up properly. Let's check on the status on Photoshop. Looks like it is still wrapping up generating the metadata file. So while that continues, what I'm going to go ahead and do is take a look at our Qt Creator IDE. And internally here, I'm going to create a new project as well. It's going to be a Qt for MCU application. And I'm going to name it the same, DS to MCU. And so this is going to create a developer-centric project within the same folder as the designer-centric project. So we'll both be working on the same code as we go back and forth. So it's warning me this project already exists, but that's okay. For a developer, we are more concerned about things like the compiler and the things that you're going to use to build and load. So we have to select some compiler kits. That's not necessary when you're working in Design Studio because everything is run through a predefined compiled runtime. And so that really simplifies the process of building out your UI. It's warning me and asking if I'd like to overwrite these other project files, which I don't, because I'll use the ones that we develop in Design Studio. So we'll leave them uncheck them to leave them as is, and hit OK. And now we're looking at the same DS to MCU QML file that we had in Design Studio. So again, if I take a look at that in our text editor, we have the same file here. All right, Photoshop should be done. Yes, so we're done with the export now. And one thing I noted when I was preparing this file, we had a number of these dots that are used as indicators for the values around the various speedometers. And by moving those out into their own artboard here, which I called the meter mark, I'm able to basically reuse those and avoid having to import separate image assets for each one. And that's an optimization that's worth noting, especially when you're dealing with a microcontroller where you have limited RAM and flash space to work with. You don't want to have to bake in 50 different images for the same look and feel. And so by doing this, I'm able to reuse that and avoid that extra overhead. All right, so going back to Design Studio, we're gonna take a look at importing these assets straight out of Photoshop. So if I go to my Assets tab up here in the library, and I go to Add New Assets, I'm gonna browse to the folder where I exported, which is the DS to MCU assets. And there's this metadata file right here. So I'll just open that, and that'll bring into the import wizard. For this first time around, I just want to import assets and I want to generate the QML source code. So I'll just use the defaults and click import. And this takes just a couple of minutes, not minutes, a couple of seconds here to finish up. So we're generating actual QML source code here based on the data that came directly out of Photoshop. You'll notice there's a merge QML option right here. And that really enables sort of an iterative development process where perhaps a designer or a UI flow team want to provide an initial draft to the development team, but they want to continue to iterate in the tools they're familiar with. And so you're able to use the merge feature to merge new changes into the existing project without overriding the changes that the development team may have added on top. So really enabling kind of a rapid iteration, which enables you to get quick feedback from customers and UX designers, etc. So what you see over here is we have all of our image assets have now been copied over, and they're present here. And so in order to make use of these, I'm going to import them. Let's add quick controls here. And I'm going to add the cluster tutorial _1 folder. So this is where the import brought all of our code. If I take a look at my new project folder, here's DS to MCU. So I now have my main source files, and this import process added the cluster _tutorial _1 folder. And that's based on the name of the Photoshop file. So that's, if you want that in a different folder, you can name it differently and it will drop in there. But you can see here's the QML components that were generated. Here's the assets that were copied in. And so those are all present now in our project. So by adding the QML import, I've told Design Studio I have some new components in this subfolder. And if I go back to my QML types, you can now see under my QML components, I have a number of options here. So I've got the main file here, and I've got the various other components like speedometer and tachometer, fuel gauge, etc. But all I need to do is drag the main file into my rectangle. And so what we see is essentially exactly what we had in Photoshop, now present in Design Studio. And if I actually want to run this QML, I can click the play button here, and I can go ahead and run that in a simulator here on the desktop straight out of Design Studio. So this is now in the developer world and now in QML source code. One of the nice things, and again, going back to that artboard structuring within Photoshop, and Sketch works the same way. We have this, the little chip icon here next to main file in the navigator indicates that this entire component is a component, which means that there's content within it. So if I right click on it here or in the navigator, I can choose this go into component option. And essentially I'm gonna dive down and take a look at the objects that are composing that component. So I've got my speedometer, my tachometer, my fuel gauge. I've got an ISO panel for if I want to add ISO icons, and a gearbox here where I can create some states, etc. And you'll notice each of these is in turn a component. And so every artboard and every layer group that was specified as a component in Photoshop turns into its own QML file that's then composed of images and text that we can customize like this. So taking a look at what I want to start with here, the background is something that I wanted to note. If I go into this background component and take a look at what I have here. So yeah, this is, just collapse this a little bit here. So what you can see is my background images, and that's great. When you're dealing with a microcontroller, all of your images are expanded generally to full resolution and compiled into the binary. So they take up a maximum amount of RAM and flash space. So when you're developing for a microcontroller, it's really helpful to identify whether you truly need some of these large full screen backdrops that are kind of complex. And so in this case, when I use the eye icon to kind of turn these on and off, I can see that like really the important part here, I've got this neat little kind of cutaway. I want to keep that. This background too is really just a gray backdrop that it's got a nice gradient to it, but the question of whether that's worthwhile to impact potentially performance or load times, I might choose to delete that. And this background 3 gives us kind of this interesting kind of looking, texture to the UI. But again, I think for the sake of a microcontroller, I would probably remove backgrounds 2 and 3 and replace them with a solid colored background that's based on a rectangle. And so to do that, what I'm going to do is I'm just going to highlight them and press delete, and delete 2. I'm going to delete 2 and 3. This backgrounds component, kind of top level, if I look at my text editor, you can see it's an item. I'm actually just going to convert that over. I can do it here by hand. I can do it over here in the property editor. But since I'm here, it's easy. I'll just change that to a rectangle, which is another basic type in QML. It's essentially an object that has height and width and can have a color value. And so those color values can be defined as CSS. Oh, excuse me. Just a minute. Apologies. All right, we're setting up a color, so I can use CSS style color values, but in my case, I want to actually specify that here using the property editor. I know my value is roughly in the 5400 range, so I can type it in here just as easily. So I'm going to do 54, 51, 58, which gives me a kind of a gray, kind of a warm purplish gray background. And when I turn on and off, so there's the background, and when I turn my foreground back on, we get that nice background component that looks about the same, but it's going to be a lot more efficient when we're working on a microcontroller because that won't take up so much RAM. Okay. So as I'm gone down into each of these subcomponents, there's a breadcrumb trail here. So I want to go back up now to the main file. And when I go back up, all of my look and feel is refreshed. And now we're going to go ahead and take a look at making some customizations to the speedometer. So I'm going to dive on into this component. And so one of the first things that I need to do, you'll notice that I have this white arc where the others used a red arc. And that's because I'm going to use a nice, convenient class for colorizing this arc over time and being able to programmatically modify the value. And to get that, I'm going to have to import the appropriate QML module that has that component for me. And so I'm going to do that here in my .qml project file. So first of all, I am going to add cluster tutorial _1, which is that subfolder that was added when we did the imports. And then I'm going to add a path on my local system to where we can find this additional component that I need. I'll save the project file, and that will enable us to make use of that component within Design Studio without any complaints. So now that I've added that, I need to go and add my, where is my, I'm going to type in a new import. Sometimes they show up in here, and other times, just depending on the folder structure, we need to do this a little bit by hand. But quick ultralight. Extras. 1.2. If I can spell ultra, we should be in better shape. All right, here we go. So it's reparsed it and found that module. And so that's located in a subfolder of the Qt for MCUs project. So it's all documented as types that are available to you for MCU projects. All right, so now what I want to do is go find my speedometer arc image here. And over in the navigator, I'm going to, I've named this colorized. So this is an image that I'm going to change into a colorized image. So this is the ID, speedometer, current colorized, and I'm going to change the type from image to colorized image and save that. And now, when I take a look at it, I have in my property editor, I have an additional color property that's provided by that type. So I know that the value that I want to specify is this 32 ABA. Now, because colorized image is special to Qt Quick Ultralight, the Design Studio 1.5 version that I'm using today is not aware of it, so it doesn't know how to render it other than that it is based on an image, and the image source is this PNG. So I won't get the color reflected in the current version of Design Studio, but it will be reflected in the project, and it will be reflected on the device. And if I run this within the QML editor, I believe we will see that color as well. What am I seeing? There we go. Okay, it's upset about, oh, a type, constants. Let's take a look at where we're using constants. That. So it's complaining that a type can't be found that I'm referencing. And let's see, speed dial component, type constants is on, oh, it's because I'm importing the DSMCU. That was an accidental add, I don't need that. There we go. So now I've got the color that I want to see. So that took the white image and it provided this color programmatically. And that's going to be helpful as we turn this into something a little more dynamic and fun to look at. All right, so we'll go back into the design mode, which is this little pencil mode icon over here. And so what I want to do is I want to export this color property so that I can manipulate it programmatically later on. So by clicking on this little nut icon next to the property, I have a few options. I can reset the value to the default. I can set up a property binding, or in this case, what I want to do is export this as an alias. And looking in the source code, what this has done is it's added a property at the top of the component that's an alias to the color value. And it named it automatically based on the ID. And this essentially provides a public API for this component so that we can manipulate the value of color outside of this component where we're making use of it. One other thing that I want to add for this speed value is a new property to actually contain that. So if I go to this properties tab down here, you'll see it. Here's the alias property that we just added. But I'm also going to add one manually. I'm going to name this speed value. And the type of this property is going to be, we'll just make it an integer to be nice and simple. And so it'll default it to a value of 0. So this will add a public API for the speed value. I'll go ahead and save that file. And what I want to do now is I want to manipulate the needle on this so that we can associate a rotation with that particular value. So within Qt for MCUs, the ability to rotate images was added in a recent update. And so Qt Design Studio still has those properties marked as not available for this configuration. So I'm going to lie to Design Studio in my QML project and tell it this is not an MCU application. And we'll go back and manipulate that rotation property because we do support rotation now of images and text, and we'll be adding additional options in upcoming releases. And as Design Studio is released, they continue to keep up with the new features that are available in the Qt for MCUs offering. So if I click here and click on the drop down, I have a little slider so I can, drag this to manipulate and see, ooh, I'm rotating the wrong thing. I'm rotating the whole component. Let's undo that. I'll just reset the value. I'll go back down to my actual image and we'll go to rotation. And there we go. So now if I zoom in, we can see the needle rotates a bit. It's a little too much. So what I do was I set this, and I did this math ahead of time, so I know it should be about -205. And that'll put us here at about a 0 mark on the speedometer. All right, so now we're going to take a look at something that's a very powerful feature of Qt Quick and QML, and that's called binding. And that's the ability, so a binding is a dynamic expression that you're able to use to create and update values as other properties change. And so in this case, what I'm going to do is I'm going to start at a -205. So that's the 0 point for my speedometer's rotation. And then I'm going to add the speed value that we added as a public property to the speedometer component. So that's the speed. If I start typing, it'll fill in dial component. And the dot operator reveals the properties that I can select. And again, if I type speed, there's the speed value property that I just added. Now there's going to be a factor here to multiply it by, and I did this math ahead of time as well, and it's 1.5. So I want to rotate this for each mile or kilometer per hour I change. I want to rotate this by 1.5 pixels or rotation degrees, basically. So when I hit OK on this, it stores this as a property binding instead of a static value, and that's indicated by the little linked chain here. And so that means that this value is dependent on something else. And if I go up to my speed dial component and take a look at my properties, you'll remember when I added this, I defaulted it to a value of 0. So if I change this to, say, a value of 50 and hit enter, the speedometer needle rotates to the appropriate position. And if I zoom in, it's pointing at the dot next to the 50. And we'll see this obviously a little bit better. So if I go up to 190, we're up to 190. So we know that the rotation is now working and it's bound to the speed value. So if I change that, I'll have a good value. Another thing I'm going to change here is I'm going to bind the value of this text object to the integer that we have for our speed. So instead of having a static 140, I'm going to set this as a binding to speed dial component dot speed value. And OK. We now see this as a binding. Obviously, because this object didn't have a full, or didn't have a height or width that was dynamic or static, it's positioned it off to the side. So what I'm gonna do is fill this text box to cause it to fill the whole width of our dial. And then I'm gonna center it. So it's gonna be centered, and I'll center it vertically too, although that won't matter too much in this case. All right. All right, so I'm going to save this, and we're going to go up a level and take a look at the main file and kind of see how this all starts to come together with some dynamic animations. So we'll take a look at mainfile.ui.qml. So here we are. We've got our colorized look and feel on this. It's got a 0 value right now for the speedometer. And if I click on the speed dial component, you'll notice over here under the properties, there's a color, which is tied directly to that arc, and there's a speed value. So those public properties that I added in the speedometer are now accessible from this main file component that's using the speedometer. And I can reuse that speedometer in multiple places if I need to, and I can get that information and manipulate it. All right, and so what we're going to do to manipulate that is we're going to add a timeline, which is one of the really fantastic features that Design Studio brings to the development workflow. So we can add a timeline, and it includes an animation that you can use optionally. I'm going to change a few properties. So I want my timeline animation to take place over 3 seconds, so 3,000 milliseconds. I'm going to have it ping pong, which will go forward and backward. And I'm just going to have it do that continuously so we can see something moving dynamically. And we'll close this. And we now have a timeline that we can set different properties on. There's a couple of different ways we can do this, but the easiest is to turn on this auto key feature, which is sort of like a recording of properties that I might want to change. And so if I drag my timeline and say, here at about 400, frame 400, over, I want the speed value to be, let's have it sit at about, we'll say 90 kph. you'll see that now we have a new entry here for speed value, and it's sitting at 90 kph. Let's sit there for about a couple of hundred frames. We'll set the value to 90 again, and then we'll go ahead and continue up. At the final frame, we'll go ahead and max it out at 200. And just to go back to and set a keyframe here at the 0 time, I'll modify that to 1 and 0. So now what I have is an animation, and the jumping is a bit of an artifact of the renderer. If I move a little slower, it won't jump around quite so much. And when we run it smoothly in the actual application, you won't see that artifacting. But as I drag through, you can see how that changes over time. Another thing I want to do is that once I get over, say, 100 kph, well, let's set it to 130. Once I get over 130, we're gonna start to change the color of this arc to warn the driver that you're getting a little bit fast. So we'll set an orange color here, and maybe if they max it out at 200, we'll say, hey, you know, that's enough. And so the color will be, you know, interpolated linearly over time. And so if I don't want it to change until I get up here, what I'll do is I'll set I'll jump to this keyframe. I'll step back 1, so at 715. I'll set my color back to the default value that I set up, which was, what was it? 32 ABBA. And that'll help create kind of a seamless, you know, no indication. And then once we pass that 130 kph, we'll move to orange, and then we'll transition from orange to red. And obviously I could add additional keyframes or to make that transition a little more smooth. And we'll just stop the recording of property changes, and let's just run this and see what we get right now in Design Studio. So we sit at about 90 for a half a second, and then we move up, and then we change over time. Yeah, that's a fine starting point. All right, let's take this over into the Qt Creator IDE and actually compile it for the device and see it running on an actual microcontroller. All right, so to do that, we have created that project already, and there's a few things I need to add to my project file to let it know about the new components that we've just created in Design Studio. So one of the first things I need to do, and I'm gonna cheat just a little bit to speed things up a bit. First things I need to do is recurse through my subdirectories to find all of the QML files that I want to add. So I'm going to use a cmake command to recurse through. It will populate a list, and then we'll add that. The other thing I need to do is recurse into the image folder so that we can add resources to this project. So I'm going to recurse through the cluster tutorial subfolder for any .png files. I'm going to add those here in the project. Because I'm using a timeline, I need to link in that library. So I'm going to add that here under the target link libraries. So we have the QUL : quick ultralight timeline. And finally, I need to bring over some fonts, which I didn't do yet. So Design Studio made use of those fonts that are, because they're already installed on my Windows computer. But the microcontroller, we actually have to compile and load those fonts on board. So I'm going to copy this into here, and I'm going to open my fonts folder. I'm going to copy those fonts over from my cluster assets. Actually, I'm going to grab them out of a previous copy here I made. So in my fonts, I've got 3 here that I've added: the Cherry monospace, ExoThin, and IBM Plex monospace. So I'll just copy this whole fonts folder and bring that into my DS to MCU. And that's what I'm telling it to do here. Use the current directory and the font subfolder, as well as the default fonts directory for any text that hasn't had a font specified. So that's right here. All right, and saving this file, the project will be parsed. Looks like I may have missed something here. Let's see what it's complaining about. Run CMake. Does not match the target. Used to generate the cache. Okay, I need to clean my cache. Clear the CMake configuration and rerun CMake. These are the wonderful little pain points that developers have to deal with that Design Studio helps avoid. So you can build your UI without having to deal with these kinds of configuration issues. All right, now you've got a successful build. I'm going to actually build this first using a desktop simulator so we can see it on the shared screen. And then after that, we'll load it on the device, and I'll use my camera to show that in action. So we'll go ahead and click play, and we'll build and run that. It's like I may have forgotten to add a line. We'll see how it runs. Yeah. Yeah, it's a compile issue. I forgot I needed to add the compatibility path for the colorized image. Okay. Let's try that and rerun it once it configures. I may have one other thing to adjust, it looks like. We're gonna I think I have some stale output from a previous run here, so we'll build and run this one. And so what Qt for MCUs will actually do is take the QML files that we've built. Yeah, there's still a concern here. It will actually compile those QML files into C++ source. And that is part of how we're able to get our application to fit into such a small binary size. Okay. Seems like it's not happy with this alias property. We can take care of that by converting this over into an actual color value here in the speed dial component. So I have done this with aliases before, but for some reason it is not happy with that. So I'm going to change it from an alias to an actual color value. And so instead of working like a pointer, it's going to actually store the color value here. And so instead of making this a link, I'm going to bind in the other direction. And that means I go to my colorized image, and I'm going to set this value as the default. And in my colorized image, I'm going to bind color to speed dial component dot speedometer current colorized color. Let's save that. And let's see if that will compile happily for us. Excellent. All right, so we've got a good compile. Now we can run this. And all right, so what we have here is actually an application binary, an exe that's running. So this isn't being interpreted any longer, like Design Studio did through a runtime. And the fact that it runs on the simulator means we're ready to try this out on the hardware. So to do that, we'll just go ahead and select our MCU kit for my STM32. That will reconfigure. And once it's finished, clicking run will configure, build, and flash it to the device. All right. Do the final kit configure cache, and then I will bring my camera in so you can see this running on the device. Hello. We're linking up the binary, and then we'll begin the flash process. Okay, finished linking. You can see the ST programmer is running. I'll bring this up here. Okay. So one thing you can see from the output here is that the overall binary size for this was 5 megabytes. So the overall binary for all these images running, as well as all the code space and everything else that goes into this application right now, is about, what I say, about 5.2, 5.25 megabytes total. And so we're able to fit it on this display, able to run it smoothly on a microcontroller. I think this one sits at about 600 megahertz. It's the STM32F7, so fairly low powered. But we're able to take advantage of the software graphics acceleration that ST provides. They call it their ChromArt accelerator. And so our runtime takes full advantage of that, and it's just a fantastic product. And so here you have it. We have our first application kind of running on a microcontroller from Photoshop to device. And so I think that's all that I have at this point to show. Christine, if you want to open up for questions, if anybody has any, I would be happy to take those.
All right, thanks for that, Corey.
Yeah.
So don't be shy. If you have a question for Corey, go ahead and unmute yourself, or you can raise your hand and I'll unmute you, or enter your question into our group chat.
While you're thinking about them, I appreciate everybody tuning in and listening.
Hey, Corey, this is John.
Yeah, John.
You have customers taking advantage of this technology, right?
Yes, absolutely.
And have they been able to put it on such a small footprint in the past? And if not, what is this allowing them to do with the rest of their build around if it's a device that they're building?
Yeah, no, up until we released the Qt for MCUs product, we couldn't fit on this small of a footprint. The Qt Quick runtime depended on a discrete GPU or at least graphics acceleration, and the full Qt stack. So this is a brand new offering, and we're continuing to release on a pretty regular cadence to get footprints even lower, memory utilization even tighter, and also adding customizations. So with recent releases, you can do some flags in your compile project to customize what things get compressed or decompressed at runtime and where different elements of the application live, so you can kind of be a little more flexible and get those applications on the small footprint. And what was the second part of your question, John?
Yeah, no, so we also can help to reduce their hardware costs as well, right? We're able to achieve such nice user experience with the UI and graphics on such a small device that, it traditionally would require, a microprocessor versus microcontroller.
Right. Yeah. And yeah, with that, you have a whole other host of issues that you have to bring in, like building out a board support package that supports your chosen processor and peripherals and things like that. And so Qt for MCUs really takes care of a lot of that work for you. And then, yeah, the cost on an MCU in bulk is dramatically lower. You also have benefits like power consumption that's dramatically lower for these types of devices. So yeah, it's absolutely where it's kind of different from what we've offered in the past on our device creation project.
So this is Shrikant here. I have a question. I have two questions. One is, do you have a set of MCUs that you have a support for? And the second question is, if you have an MCU and an MPU, can the same application run on both the devices?
Yeah, great question. Right, especially that the second one really talks to kind of what Qt is all about, and that's cross-platform and scalability. And so I'll answer that one first. And the answer is yes. What you write on a microcontroller UI can be used on a full application processor in the full version of Qt for device creation. So going the other way, there's a little bit of adaptation, right? Because some of those there's some custom types and some smaller subset of types that we've written for microcontrollers in order to be able to fit on the footprint that's available. Most of the key ones are there. So a lot of the Qt quick controls that you may be familiar with from Qt for device creation are available for you on MCUs as well. So scaling up is not a problem at all. Scaling down sometimes requires a little adjustment, but it's nothing dramatic. And then to your question about what's supported, we have a number of devices that are supported. I think we're up to about 7 or 8 that are supported out of the box. And so the way microcontrollers typically work is the vendor, like an ST or an NXP or Renesas, they'll provide an evaluation kit. And it's got, one of their key processors. Sometimes it's got a display attached and built in and several peripherals. And it's designed for you to explore the capabilities of the processor with a complete set of options. When you go to production, typically you'll customize that board and choose an option that has a limited set of peripherals that are just what you need for your project. And so the ones that we support, we start with the evaluation kits so that you have the entire spectrum of peripherals supported. And then when you want to go, if you choose to go to one that's not one of their evaluation kits, then if it's one that requires additional board support, our professional services can help you work through that process. But you also do get the source code with your license, so you're able to adapt it yourself and make that transition if that's what you'd want to do.
Thank you, Corey.
Yeah, thanks for the question.
All right, do we have any more questions from our audience? Okay, moving on. We do have another upcoming event, our very own flagship event of the year, the Qt World Summit Online. It's happening online in a virtual 3D rendered Palm Springs, and we are hosting this in our Americas time zone at 9 a.m. to 2 p.m. Central Standard Time, and in Europe at 9 a.m. to 2 p.m. Central European Time on October 22nd. We invite you all to please join us and watch our riveting talks. You can fly your avatar into our 3D rendered conference and join and talk with our Qt experts live, and also interact with the other attendees either by the pool or just walking around and checking out the demos. Thanks for joining us. And if you have any questions, feel free to connect with us at info@qt.io. Thanks again, Corey.
Thank you very much.